Hello everyone and welcome to 591 Lab. My name is Rafi Saeed and today we are going to discuss about sample exam question of AWS Solution Architect Associate. So let me introduce 591 Lab first. 591 Lab is a top IT training and certification exam brand in China, Hong Kong, Taiwan and Singapore. Our mission at 591 Lab is to provide our client with exceptional exam preparation experience for certification in AWS, Cisco, Huawei, Aruba, Juniper, Palo Alto and Fortinet exam tracks. Today we are going to discuss about some interesting exam topics: IAM, EC2, Route 53, DynamoDB and application load balancer. So let's move on the first question. A solution architect is designing an AWS identity and access management authorization model for a company AWS account. The company has designated 5 specific employees to have full access to AWS services and resources in the AWS account. The solution architect has created an IAM user for each of the 5 designated employees and has created an IAM user group. Which solution meet these requirements? So before discussing each option, let's jump into the console. Alright, so we have logged into the console. So the group is there. First we need to add all the 5 users into the group. Let's add the users. Alright, so the best way to provide administrator access, go to the permission, add permission, attach policies. So here is administrator access. Just select this manage identity policy and attach the policy. This icon shows that this is AWS Manage Identity Access Management Policy, which is currently associated with the group name 591 Lab, and all the 5 users are already part of this group. So this policy will apply on all those 5 users. Alright, so let's discuss available options. Option A, attach the administrator access resource-based policy to the IAM user group. Place each of the 5 designated employees IAM users in the IAM user group. So resource-based policies are used to grant permission on AWS resources, not IAM users or groups. This option is not suitable for providing IAM user permission. Option B is attach the system administrator identity based policy to the IAM user group. Place each of the 5 designated employee IAM user in the IAM user group. While identity based policies are the correct choice for IAM user permission, the system administrator policy is not a standard AWS managed policy. You would typically use administrator access for full access. Option C is attach the administrator access identity based policy to the IAM user group. Place each of the 5 designated employee IAM user in the IAM user group. So this is the correct choice. The administrator access policy is the standard AWS managed policy that provides full access to AWS services and resources. Attaching it as an identity-based policy to the IAM user group ensures that all the IAM users in that group inherit the permissions. Option D is attach the system administrator resource-based policy to the IAM user group. Place each of the 5 designated employee IAM users in the IAM user group. Similar to option A, this option suggests using a resource-based policy which is not appropriate for granting permission to IAM user or groups. Alright, so let's jump into the next question. A company stores multiple Amazon machine images or AMIs in an AWS account to launch its Amazon EC2 instances. The AMI contains critical data and configuration that are necessary for the company's operations. The company wants to implement a solution that will recover accidentally deleted AMIs quickly and efficiently. Which solution will meet these requirements with the least operational overhead? So before discussing choices, let's jump into the console and see how we can create a retention policy. Alright, so let's find out recycle bin. Create a retention rule. Let's give it to the name. Description is optional, it's up to you. And the retention setting, what kind of resources you want to back up, like EBS volumes or Amazon machine images or AMIs. So in that particular case, we are going to take backups of AMIs. So let's select AMIs. Apply to all resources, and if we want to take backup of specific resources, then you can provide tags here. So let's apply to all resources for now. This is the minimum and maximum duration period. So let's set it to the 7 days. And just create retention rule. So going forward, this rule will basically all the AMIs, whenever you delete any AMI, it will be stored into the recycle bin for 7 days, and after 7 days it will be permanently deleted. So our choices are: create Amazon Elastic Block Store, a snapshot of the AMIs, store the snapshot in a separate AWS account. While EBS snapshots are useful for backup and recovery, this option involves more manual management. There is no inherent protection against accidental deletion. Storing a snapshot in a separate account adds complexity and may not be the most straightforward solution. Option B is copy all AMIs to another AWS account periodically. While copying AMIs to another account provides a form of backup, it introduces additional operational overhead and may not be the most efficient solution for recovering accidental deleted AMIs. Option C is create a retention rule. The recycle bin is a feature in AWS that helps you recover deleted resources, including AMIs, within a certain retention period. By creating a retention rule in the recycle bin, you can specify how long deleted resources are retained before being deleted, as we have seen in the previous demo. So this answer seems to be correct. Option D is upload the AMIs to an Amazon S3 bucket that has cross-region replication. While using S3 for storage is a valid option for certain scenarios, cross-region replication is not designed especially for recovering deleted AMIs. It adds complexity and may not be the most straightforward solution for that particular use case. So creating a retention rule in the recycle bin, it's a built-in AWS feature that is designed for recovering deleted resources with minimal operation overhead, making it the most suitable option for this scenario. Alright, so let's jump into the next question. A solution architect runs a web application on multiple Amazon EC2 instances that are in individual target groups behind an application load balancer. Users can reach the application through a public website. The solution architect wants to allow engineers to use a development version of the website to access one specific development EC2 instance to the test new feature for the application. The solution architect wants to use an Amazon Route 53 hosted zone to give the engineer access to the development instances. The solution must automatically route to the development instance even if the development instance is replaced. This solution will meet these requirements. So before discussing all those options, let's jump into the console. Alright, so we are logged into the console and the application load balancer is already there. This is the URL of the application load balancer. So let's jump into the Route 53. Alright, so this is the Route 53 dashboard. Just go to the hosted zones. So this is our hosted zone 591lab.com. Let's click on it. We have to create a record. So every request or the development server forwards to our load balancer. So let's create a record. dev.591lab.com is just fine. Record type should be a record, but we have to enable alias if we want to forward requests to any specific load balancer. In that particular case, we would like to forward all the requests to our load balancer, so we have to select the endpoint. It should be application or classic load balancer. Select the region, as we have created load balancer and auto scaling group within Virginia region. So let's select the region Virginia, and as you can see there, the URL of our load balancer is already there. So just select this URL. So click on create records. Alright, so record set is created, and going forward, anyone browse this URL dev.591lab.com, which will forward all the requests to the load balancer. Let me show you the load balancer URL as well. So this is our load balancer, and as you can see the URL, here you can see the URL. This is the DNS name for which we have created the A record. And if we browse this URL, so this URL is basically browsing the website. This is a sample WordPress Bitnami website. So let's jump back to the question. Alright, so the first answer is create an A record for the development website that has the value set to the ALB. Create a listener rule on the ALB that forward request for the development website to the target group that contains the development instance. So by creating an A record for the development website with the value set to ALB, we ensure that requests to the development website are initially directed to the ALB. By creating a listener rule on the ALB, we can configure it to forward requests for the development website to the target group that contains the development instances. This allows for dynamic routing based on the specified condition. So this seems to be the correct answer. Let's discuss other choices as well. Answer B is recreate the development instance with the public IP address. Create an A record for the development website that has the value set to the public IP address for the development instance. Recreating development instance with the public IP address introduces manual steps and potential issues. Additionally, if the development instance is replaced, the public IP address might change, leading to potential disruption. Option C is create an A record for the development website that has the value set to the ALB. Create a listener rule on the ALB to redirect request for the development website to the public IP address of the development instance. So redirecting requests to a specific public IP address introduces complexity and it is not flexible. It also requires manual configuration and does not provide the automatic routing requested in the question. Option D is place all the instances in the same target group, create an A record for the development website set to the value to the ALB, create a listener rule on the ALB that forwards requests for the development website to the target group. Placing all instances in the same target group and using a listener rule to forward requests to the target group would not allow for isolating the development instance. For testing purpose, it does not meet the requirement of directing requests specifically to the development instances. So option A is the most appropriate solution for the given requirements as it leveraged Route 53, ALB and listener rule to dynamically route request to the correct target group containing the development instances. Alright, so let's move to the next question. A company stores critical data in Amazon DynamoDB tables in the company's AWS account. An IT administrator accidentally deleted a DynamoDB table. The deletion caused a significant loss of data and disrupted the company operation. The company wants to prevent this type of disruption in the future. Which solution will meet this requirement with the least operational overhead? So before discussing the answers, let's move on to the console. So this is the database or the table which we want to protect for accidental termination. Let's click on the table. Go to additional settings. Scroll down and you can find out termination or deletion protection. Just turn this feature on. So option A is configure a trail in AWS Cloud Trail, create an Amazon Event Bridge, rule for delete action, create an AWS Lambda function to automatically restore deleted DynamoDB tables. While CloudTrail and Event Bridge can be used to capture events and trigger actions, the suggested solution introduces more complexity. It involves creating a Lambda function to automatically restore deleted tables, which may have its own operational considerations. So this is not the correct answer. Option B is create a backup and restore plan for the DynamoDB tables to recover the DynamoDB tables manually. While creating backups is a good practice, the solution relies on manual recovery. Manual recovery can be time-consuming and may not be suitable, preventing disruption caused by accidental termination. Answer C is configure deletion protection on the DynamoDB table. Configure deletion protection. This option allows you to enable deletion protection for DynamoDB tables when deletion protection is enabled. It helps prevent the accidental deletion for DynamoDB tables by blocking any delete table request. So this answer is correct. Answer D is enable point-in-time recovery on the DynamoDB tables. Point-in-time recovery is useful for recovering a table to a specific point in time, but it may not prevent the accidental deletion itself. Additionally, it adds operational complexity and may not be the most straightforward solution for preventing accidental terminations. Configuring deletion protection on DynamoDB tables is the most straightforward and least operational intensive solution to prevent accidental deletion and ensure the integrity of critical data. Alright, so the next question is, a company web application that is hosted in AWS recently increased in popularity. The web application currently exists on a single Amazon EC2 instance in a single public subnet. The web application has not been able to meet the demand of the increased web traffic. The company needs a solution that will provide high availability and scalability to meet the increased user demand with reviewing the web application. Which combination of steps will meet these requirements? Select two answers. So before discussing those answers, let's jump into the console and see how we can configure application load balancer subnets and auto scaling subnets. So this is the application load balancer, and we can go to the network mapping. Here we can select our subnet, or if we want to change our subnet, we can change it over here. So let's add subnet. Currently we have 2 public subnets. If we want to assign more subnet, then we can select from here, which we don't need to add right now. So let's back to the load balancer, and this is the URL basically, which is on the public subnet. So whenever anyone browses this URL, it will redirect to the website. So as you can see there, the website is running on the public subnets, and on the other hand, this is our auto scaling group, and both our instances are running via auto scaling group. And if you want to change the configuration of your subnet, which should be part of your VPC, the one which is configured with the load balancer. So this is our auto scaling group, and we can configure our subnet as per our desired need. So go to the network, and if you have private subnets as well, then you can select from over here. As you can see, I have few private subnets which I can select from over here, but all the public and private subnets should be part of the same VPC, the one we are running load balancer with and auto scaling group. So both subnets or VPC should be the same. So this is how we can configure our load balancer with the public subnet and our auto scaling group with the private subnet. But both subnets should be part of the same VPC, and we should use auto scaling and load balancer within the same VPC, otherwise they won't work. So the choices are: option A, replace the EC2 instance with a larger compute optimized instance. This does not provide high availability or scalability, and replacing with a large instance might still have limitation. Option B, configure Amazon EC2 auto scaling with multiple AZs in private subnet. Auto scaling allows you to automatically adjust the number of EC2 instances in response to change in demand. By configure auto scaling with multiple AZs or availability zone, you improve fault tolerance and ensure high availability. So the option B seems to be correct. Option C is configure a NAT gateway in the public subnet to handle web requests. A NAT gateway is used for outbound internet traffic from private subnet, and it's not suitable for handle incoming web traffic. Option D is replace the EC2 instance with a large memory optimized instances. Similar to option A, this does not address high availability or scalability concern efficiently. So option E is configure an application load balancer in a public subnet to distribute web traffic. Application load balancer distribute incoming web traffic across multiple EC2 instances, providing both scalability and high availability. Placing the ALB in the public subnet allows it to receive incoming requests, while the EC2 instance can be in private subnet for security. Option B and E together provide a solution that enables auto scaling across multi-AZ and distribute incoming web traffic using the application load balancer, ensuring both high availability and scalability for the web application. So the correct answers are option B and option E. So this is it for today. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab. Help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.